So now when we come into the Kibana interface and we find this APM tag on the left, we can look under the list of services and find the service we just created, Packed Fowie Flask 2. This is telling us that we're using the Python agent, 31 millisecond average response time, so that's the HTTP response time. The number of transactions per minute, so in this case we were getting 47 transactions per minute on average. Errors per minute, 56 errors per minute on average. So we'll start by clicking on the service name, and this is the part I love. So let's look at the last 15 minutes. We have request response times, a 99th percentile finishes under 93 milliseconds, the average is 33 milliseconds. Let's see, the 95th percentile is 55 milliseconds, so these are great requests per minute over time. So I've only been running this recently, but you can see it will go back if we have it. And here's a fun part. It takes our mappings, our API mappings from the Flask application, and we can see we have 1 millisecond response time for our API users. That's the get to get the big list. And you can see that it responded really quickly. And then we have our puts where we're creating or updating. This is the one that's actually interacting with our database. So let's drill into this one, and I can show you the great parts about application performance monitoring. So once we get here now, we can see a timeline of what we do. So response time distribution is just showing like the most distributed here. But here at the bottom, I'm getting ahead of myself. This is the fun part. So we can say, okay, in this put command, we had a connection, is my guess, this first part, a connection to the SQLite 3 connect use. Yeah, that is the connect command to the user's database. It took next to no time, like hardly any time at all. Then we had the insert. So clicking on that insert line, we can see the line of code that it happened on. We can see there was a database transaction, and it took 2 milliseconds, or 2.8% of the total time of this API call. This is awesome. It even shows a SQL statement that we executed. So let's click on that, or close that. UI bug. I hit escape to close it. Okay. And then here's a cool part too. We can go and we find this example transaction. So I don't believe they store every transaction, but they show a sample. So here we can see that this is an update to user 341, HTTP 200 results, and no users since I don't have authentication. So I clicked on the link to show the details in the Discover tab, and wouldn't you know, here's everything you need to know about that HTTP transaction. I mean, we have environment information, headers from the HTTP request, service framework, Flask framework, Python. Apparently I'm running Python 2.7.5 for some reason. This is a transaction duration 64 seconds, transaction ID, view spans. Let's see what that is. I'm not sure what view spans is. Okay, so this was the individual traced transactions. So the actual insert here, you can see we insert into users. I'm curious if we can find the parameters we passed. Doesn't look like the parameters are in here, and that's okay. All right, so we have that HTTP request, the transaction tracing, view surrounding documents. Here we're kind of pivoting around it based on time. So this is just showing you all aspects of your application. My favorite part about this is that transaction view that shows you here the breakdown. So we can drill through again and look at all the requests. So this is where we should be able to find, the body was redacted, they hide that. The response, system information that we were just looking at. So these are different ways we can see it. We're running a Python process with the PID 7840, no user information. This is the kind of data that you can get out of the APM module, and this is only going to get better as time goes on. So I'm really excited about this feature, and I can't wait for it to get wider adoption. All right, in that video we covered APM. We covered from setup, configuration, running the application, showing how we get it into the Kibana user interface, and that's the end of this section. So next videos, we're going to talk about scaling your Elasticsearch cluster. So this is a big deal. When we talk about Elasticsearch, we can use it as kind of an embedded application within something else, but in a lot of use cases when you're taking log files, log messages over time, or you're collecting network data, or you're collecting transaction data or statistical data, if you want to keep this data for any amount of time and it's a large size of volume, you're going to need a big Elasticsearch cluster. So we're going to talk about a bunch of things about scaling your cluster.